Okay, we are on the clock. Shall we start? Okay, welcome everybody to this first core working group session at the IETF 110 meeting. Chairs are Marco Tirocami and Jaime Jimenez, who couldn't be here for this meeting. We have the next slide to give a hint why. Next, please. So Jaime is happily busy again with his newborn son, and as we like to think, training future working group chairs. And in his place, we have a standing chair for this meeting, Karsten Bormann. Thank you very much for kindly being supportive in this occasion, and congratulations again to Jaime. Next, please. Yeah, a bit of practicalities, of course. As usual, we assume people attending the session to have read the documents discussed today. We are trying to make good use of the time during this meeting to solve open issues, especially the not well applied. More on that on the next slide. And as a reminder, blue sheets are automatically compiled in this MeetEcho meetings. I will be Jabber Scribe for this session. And I understand we have Michael Richardson as minute taker. Confirm, Michael?
Well, he's typing.
All good.
Thanks. Thank you very much. I'll also help. Otherwise, not well apply as usual. Please get familiar with those if you're not already. It's not only about IPR and patents. It's also about a code of conduct. So be polite and nice with each other. Next slide, please. Okay, please use the queue request feature on MeetEcho to enter and leave the queue. The hand on the top left of the window. You can use Jabber. I'll be the scribe. I can relay your comments or questions. And this meeting is recorded. And again, no need to fill any attendance list explicitly. Next, please. All right, and more nice news for today. We are again changing AED. The living AED is very labor right now, and during the week there will be the formal handoff to Francesca Palombini as new AD in the art area and responsible especially for core. So thanks to Barry again, and welcome Francesca. And if you two want to say something, please do.
Okay, I hesitated. I saw Francesca try to jump in. Hi, everybody. Thanks for the support you guys have given me over the time. And thanks for being an easy working group to manage and getting a lot of work done. So you'll still see me around.
Yes, just want to say thank you, Marco. Looking forward to working with you and everybody.
Thank you, both of you. Next slide, please. Right, this is the agenda for today, which is essential, including all the security-related works, also to avoid a collision with the Danish BOF on Friday. We start with group communication documents, continuing on other security works on cacheable OSCORE and combining OSCORE with EDOC, and the recent new work on cipher limits, especially applied to the OSCORE protocol. Next slide, please. Yeah, anticipating the agenda for Friday, we'll discuss open points on one of the core conf documents currently under Shepherd write-up, and look at the advanced TUS and ML documents now active. Same for new block and DynLink. These are all working group documents. And we conclude on other two documents on resource directory extensions and a new proposal on data-centric deployment for co-op. So before we move on, any agenda bashing or comments on the agenda? Anyone? Okay, next slide, please. Just done that. So next and next. So I think in January, 8974 was published as an RFC, used to be the core stateless document. Thank you very much to Klaus and Michael, especially in the final stages, and to the whole working group for this achievement. Next slide, please. And then we have a bunch of almost there documents. DevURN is already in the editor queue, and for the resource directory, we could finally see that yesterday when it was formally approved, and there are other working groups and documents that have as many reasons to celebrate about this, like especially one document in LWIG. Echo request tag also requires some final editing from Christian, if I remember correctly, to address comments from Ben and Roman. Otherwise, it's also very close to take the final step. Thanks a lot for all this work. Next slide, please. Right, we have 2 of the 4 CoreConf documents, meaning Jan Sieber and Seed, that are right now in last call until mid next week. And as Francesca suggested, we also requested for both of them an additional review from young doctors. Next slide, please. Right, as to the other 2 CoreConf documents, they are under Shepherd write-up. Young library seems to be essentially done, while there have been new open points raised during the write-up for the COMI document, and they will be discussed also with Eva Ilo in the Friday session. Otherwise, we have 3 documents post-working group last call. One is group last score, for which a new revision was recently submitted, and we have especially 2 more open points to work on. SNML Data CT has just incorporated working group last call comments, and with a little synchronization about the content of another document that was also discussed in dispatch today, is possibly ready to move forward, and same for the new block draft that has also incorporated working group last comments and is also in the agenda for the Friday session. Next slide, please. Though I think that was all for the summary. Yeah. So I think we can take as next step the set of group communication documents, and the first one in the list is Group ComBis with Esko presenting.
Yeah, I'm just checking the audio.
It works. We can hear you well.
Okay, in that case, I'll turn on the video as well.
And we can see you too. Hi, Esko.
Hi. And you can do the slides, I think, right?
Karsten will handle them.
No question. Yeah, thanks. So it's still being started on my end. No screen yet.
Start talking. My usual way of showing slides in Chrome doesn't work, so I'm using a different thing, and that of course doesn't always work either. So just go ahead and talk.
Oh yeah, okay. I'll open the slides here then. So I'll present the group communication for the constraint application protocol draft, Group ComBis. And just as a reminder of the goal, so this is intended to describe co-op group communication as a successor of the experimental RFC 7390. Now we're aiming for a standards track document. Yeah, meanwhile, the slides are visible. Great. So we'll skip this one because we've presented it a number of times. It's just a reminder of the scope of the document. So currently focused on any UDP multicast-based group communication for co-op. So the general updates, I will now go through them. So we have adapted the text to allow this thing, basically. So one server that's responding to a group request can give back multiple responses in principle. Although normally it should give back one response, but still due to circumstances you could get multiple. And now the question was how to handle this. So if in this case, the proxy is proxying a group request, the idea is now to, based on interop experience, state that the proxy will just forward all the responses, and then the application layer at the client needs to handle it. So that's also visualized in the figure. So we can go to the next slide. So what we did is we had already guidelines on forward proxies. They were revised. Now also some more information on reverse proxies is added. Let's see. Yeah, so the reverse proxy can basically do the group request. So the client will do a unicast request to the proxy will do a group request. The proxy can also handle following unicast requests. So yeah, that's basically a reverse proxy, and it's made to look like a normal server, basically. And we now also reference specifically a signaling protocol for proxies. So as we listed before a number of issues for forward proxies and reverse proxies, we now have this reference to draft Tiloka core groupcom proxy that's authored by Marco and me. And that also has a signaling protocol, as will be explained later, to address these issues. Okay, let's go to the next slide. Yeah, one major addition is the caching model. So we already have the caching at the client side, of course, of responses. And now we basically add the caching in the proxy as well. So for proxies caching, we did, well, at least Marco did a quite thorough analysis on that. And it turns out you have to work with two types of cache entries. So one is the individual cache entry for a single response from a single server. The other type is an aggregated cache entry. So that's basically one cache entry that represents an entire group of responses that corresponds to a single group request. So we have both types, and in the draft we will basically explain some rules how to handle the cache entries for both types. Okay, we'll go to the next slide. Yeah, so the caching model is as follows. So a proxy can receive a group request and then get responses from the origin service back, as shown on the picture. So what it does is it forwards each response back to the client, and also adds an individual cache entry for each response. Also, the responses get added to a list L, and that list L will basically later be used to make an aggregated cache entry that collects all the responses for that particular request. And at the bottom of the slide, you can see there's some lifetime handling also to be done for that cache entry. So it looks at the max age of all the responses to compute a combined max age for the aggregated cache entry. Okay, next slide, please. Yeah, the caching model continues. So basically, a unicast request can also be sent to the proxy, and then it can receive a response from the server to that. So the response is forwarded, and then it creates an individual cache entries or updates the existing one. And it also will look in the aggregated cache entries, basically. Let's see what it does then. Which ones? yeah, it can also basically update the aggregated cache entry with an individual response, and also that may influence the lifetime. So it will basically scan all the entries again and correct, yeah, the lifetime. So the lifetime of an aggregated entry is always the minimum of the lifetimes of all the entries that are in there. Okay, let's go to the next slide. So also the validation model is a separate section from caching. Yeah, so in the co-op RFC, this was not addressed in detail. Now we try to do that. So the validation works between client and servers, and for that we introduce a new option, the multi-ETAG option. And this can only be used for group requests. So it will basically, yeah, be like an ETAG, only that in the ETAG it also encodes an identity of the server, so that it can basically direct the ETAG option to one particular server. And the nice thing of this is that at the server side, the server doesn't have to think about, okay, what kind of ETAG should I generate so that the client can, yeah, can distinguish between all the possible servers, but it just generates an ETAG as usual. And the client can use this option to, yeah, basically pick responses that it has cached and to validate if they are still correct. So the proposal is in detail in the draft. So we have some addressing information added, encoded, yeah, in the same way as in the GroupCom proxy draft. Okay, let's go to the next one. There are no questions, at least. There's also between the client and proxy validation possible. Yeah.
I have a quick question, if I may. This this shows an eggs in the R column.
Yeah, that's repeatable here. Yeah.
But it's also a CBOR sequence. So.
That's right.
How do I know whether I start a new sequence in a new option or continue the sequence in the existing option?
Yeah, the existing option is to target one particular server in the group. And it has basically a sequence of ETAG elements in there. So that's for this particular server. If you want to address multiple servers, so you say tag 1 on server 1 and tag 3 on server 2, for example, then you need 2 of these options. So that does not fit in one option in the current definition.
Okay, thank you.
Yeah. Okay, yeah, so this was between client and proxy. So that's basically only meant to address these aggregated cache entries that are newly introduced. So you can basically validate an entire group response as a client. And in case that is still fresh, you can basically get a validation and confirmation from the cache, like, okay, this is still a fresh group response. You can use the entire thing, and there's no need to do a new group request in this case. But it can be used in get and fetch group requests. And yeah, it works for the rest quite similar to the normal co-op validation. So using the group ETAG option. Yeah, okay, let's go to the next one. Taking the time. There's also the security question, of course. What we have discussed so far is without security, or at least without end-to-end security. We also considered what can we do going through a proxy with end-to-end security. Can we still cache? Well, it turns out it's not that straightforward, but it's possible by using the deterministic requests that are introduced in this draft AMSU's core cacheable OSCORE. and it's limited to RESTful safe requests that have no side effects on the resource at the server. So like a get and a fetch, for example. So the client has to prepare this specific deterministic request to be able to do this. And response revalidation, that's not possible in all cases. So we have listed a couple of cases below. It is possible between origin client and origin service using the multi-ETAG option. But there are some complications when doing that. So if you change the request only a little bit, then it means, oh, I have to use a different deterministic request. So it gets into quite a lot of complexity to do this. So that's what we basically try to provide an overview of what you can do and what you cannot do. Okay, and next slide, please. So we have an open point, one of several actually in GitHub. I think that's the question: what is the most appropriate place for these new items that we introduced? So number one is the general rules of cacheability of responses at proxies. So this looks appropriate to be in this document, but on the other hand, we could also move it to the group.com proxy document to clearly separate that. The other thing was the multi-ETAG option that we introduced. So that's basically for a client to be able to validate individual responses from a group of servers. That looks like it could also be in a separate dedicated document because it's really a new thing here and not something existing in co-op that we want to explain in the group communication context, but it's really a new feature. Personally, I think we could also add maybe how the normal ETAG option can be used in group communication scenarios, because that's also still possible with some limitations, of course. And then number 3 is the group ETAG option. So that's basically specifically validating a group of responses at a proxy. And that could go typically also in the group.com proxy document. That's what it's about. Or maybe it can stay in group.com biz. That was a bit of a discussion points we have. So where does the content go? Okay, then next slide, please.
There is Göran in the queue. Please go ahead, Göran.
Okay. Hi, Esko. Yes, just a few questions on this. And I'm trying to understand the multi-ETAG and the group ETAG. Do you have any simple examples for when I would like to use one or the other option here? Why would I want to validate the number of requests, for example? Or sorry, number of responses in the group ETAG.
Yeah, so that's I don't have any real concrete example, but you could say that suppose you're reading status information of a group of devices, and like one of these devices, for example, has a particular large status report that I already got last time, and I maybe don't want to get it next time. So you can basically put it multi-ETAG in, just stating, okay, I have this version of your status report. Don't send it if that's still the same, basically.
Right, and that you could send. Validate. Yeah, and that you could. That's basically that you could have multiple of those.
And it can be multiple on different servers. Yeah.
Okay, and the security for that, there was some part of the end-to-end security was not possible. I mean, that's definitely a proxy to origin server, so that's not an end-to-end security secured option, right?
The details of the option itself, maybe Marco can answer that.
I think it's in the previous slide.
Oh, sorry for. stopping the presentation. I just was curious how.
But yeah,
when you,
exactly as you said, Joran, the group, here, the group tag option would essentially not be possible to use if you have end-to-end security. And the multi-tag option would not be possible for the proxy to use acting as client to the origin servers.
Yeah. Okay, but is that a problem? I mean, that this could be an outer option, right?
Right now, this is mimicking the e-tag option in Tesma properties. So it would be processed in the same way, and this would be the result.
Okay. But it was
What
basically, yeah. It seemed
what
that this.
remains is,
Go
sorry,
ahead.
go ahead.
No, go ahead.
What really remains possible is for sure end-to-end between the client and the servers.
Right. Okay. Good. Well, yeah, I can think more of it. We don't need to stop the presentation now. Please go on. Thank you.
Yeah, it opens up many things, possible things you can do, and a lot of questions. Okay, then let's move to the next slide. Oh, there's already next steps. Yeah, I think we're very quiet here. So the next steps for this draft, we have review comments received from John, still to be addressed. I think there's quite some good comments, including, okay, can we, yeah, I think that was one of the questions to make it more generic, so not only target co-op group communication over UDP multicast, but also consider which part could be applicable to yeah, another transport layer, like a non-IP groupcast for co-op. And more reviews would always be good, of course. We have now quite some new content added, so that there's really something there to be reviewed. We want to address the open points introduced today. That was the issue 11 about what goes where. And of course, there are other GitHub issues open. And yeah, doing some more testing and implementations. It would also be nice. So I think this concludes the presentation more or less. If there are any questions, let me know.
Nothing on Jabber either. Christian, please.
From the levels of maturity between the e-tags and the e-tag stuff and the rest of the group compis sounds. I think it might be a good idea to treat the e-tag into more in something like the proxy document that has no ambitions to progress in the same pace as the group the group compis, because I think that the group getting group compis out is valuable, and the e-tag things are valuable, but they will need time to hammer out the details.
Yeah, maybe some implementation work as well for the group e-tag, for example, multi-e-tag. Yeah.
And the +1 from Karsten on Jabber.
Okay. Yeah. No, that sounds reasonable. All. Yeah. Yeah. Then for the group e-tag can certainly go in the proxy documents. For multi e-tag, it's not really proxy related. So do you think it could be a completely separate document in that case?
It's not proxy related, but it's related to the transport address stuff set up in the proxy document. So maybe it could still live there because it has commonalities there.
Yeah. No, that sounds like a good observation indeed. So it could be combined, is what you're saying, because of that.
Okay.
Right.
Thank you, Esko and all, for the feedback. We can switch to the next presentation, which is the GroupoScore document. And I'll take that one. Right, yeah, this is an update on the Drupal score draft. Now revision 11 we submitted by the cutoff. Next slide, please. All right, this latest version was mostly about addressing a very good and useful review that we got from Christian on version 10. Thank you very much for that. And a number of other points we discussed and agreed on at the November meeting last year. Following that, we think we have still two open points that I'll overview shortly later. One discussed with Christian during the hackathon about admitting the recycling of group IDs in the same group, and one related to a comment we got from Ben Kadok on the list about the current usage of identity keys for both signing and Diffie-Hellman operations. Next slide, please. Right, first of all, we eventually converged to a single and simpler format of external EAD to be used both for the encrypting and the signing operations. And in simplifying it, we removed the used to be par countersign key as inner element describing the algorithms used in the group, or actually the property of the key type. And this is also much more consistent and aligned with the common context. We also clarified why we are introducing the last two elements of the array in the first place. So this is what the document body says, and it works right away with all the algorithms we have registered in COSI today. But also based on the discussion at the November meeting, we added a new appendix providing a general template to follow to build the par countersign parameter in the external EAD and the corresponding parameter in the common context for the future case when possibly more COSI algorithms will be registered with 0 or more than 1 capabilities. So it's essentially just future-friendly to be followed, and if you take it and use it today with the algorithms registered today, you end up with the main definitions that are already in the document body. Next slide, please. Okay, then we also realized that it was possible to optimize a little bit response messages by not necessarily including the KID in the OSCAR option of such messages. The KID must still be included in the response if the response is intended to a request that was protected in group mode, because the responder could be any of the server in the group. But otherwise, the exact mode used to protect the response doesn't really matter. And that especially when the pairwise mode is used allows to save pretty much bytes on the wire. We also relaxed the rules that were previously preventing recycling sender IDs altogether in the group. Well, now it's forbidden only under the same group ID. If that changes because of a group rekeying, it's possible to reuse sender IDs under the new group ID. And according to all the changes I mentioned so far, we have also, of course, updated the examples of protected messages in the draft. Next, please. Right, this is very much following Christian's comment. We try to improve also the reasons why there may be a loss, even if partially, of a security context. In case, due to memory limitation, eventually a node in the group reaches the maximum amount of recipient contexts that it can have. So if one more has to be created, it has to delete an old one to leave room for the new one. But the moment this happens, from now on, any newly created recipient context will be created with an invalid replay window that has to be fixed, assuming replay checks are still important, and they are. And in order to do that, well, either the node in question participates to a group rekeying, which of course results in changing its sender ID, its sequence number reset, or it has to run a proper exchange like with the echo option as we define in Appendix C. And as a positive side effect, you also get freshness of the just received request that was resulting into the new recipient context. This was also an opportunity to make it even clearer that remaining able or becoming again able to enforce anti-replay and achieving freshness are two different things. And freshness is the one related to achieving synchronizations with the sequence number of clients, which can be achieved using, for instance, the echo exchange. Next slide, please. Right, some editorial changes still pretty major, I'll say. We reorganized a lot the section discussing, in fact, the loss or partial loss of security context, trying to express in a much clearer way the pattern cause effect. Causes can, in fact, be loss of mutable security context because, for instance, of rebooting, or because the maximum number of recipient contexts have been reached, or the exception or sender sequence number. And the effect would be, of course, to request new key material from the group manager that can just end up in getting a new sender ID. But in a way or another, this node will reset its sender sequence number and things will be adjusted again. Section 9 defining the pairwise mode was essentially rewritten, of course, to keep the same mechanics, but now it's written as a delta from the OSCORE RFC. As Christian also requested, adding also a small number of things picked up from this document again, and it's group mode, especially when it's about support for observe. And for synchronization and achieving freshness, now we have only the echo exchange approach as Appendix C, while we just removed the other previously included approaches as they simply became moot when thinking more about them. Next, please. All right, the first of the two open points. First of all, as related, we realized something we intended all along is not explicitly mentioned, and it should. If a node rejoins the group, and when doing so, of course, it gets a new sender ID, it must explicitly terminate all the observations it has ongoing. Just as a reminder, in fact, observations are supposed to survive a change of group ID due, for instance, to a rekeying in the group. So far, we were forbidding the recycling of group IDs altogether in a group, meaning that groups cannot live forever. And that was forbidden, especially to avoid a possible problem with long-living observations, in fact. So for instance, you can have a client C1 that starts an observation with that tuple, current GID, KID of the client, partial V1, so to say. Later on, for some reason, that same client gets a new KID, totally fine. The observation continues with the same original tuple. Then the group is rekeyed several times. The GID changes because of that. And eventually, the GID drops and gets back to GID1, still fine. Problem is if a new client gets accidentally the same KID that C1 had when it started the observation. And by really bad luck, that second client starts totally legitimately a new observation with the same tuple. And then you have troubles because you can have one notification that matches either observation, which is bad. So we had to solve this problem to admit recycling of group IDs. Next slide, please. We discussed about this during the hackathon, and we found a way to fix this. It's sufficient to introduce a little more logic on the group manager. Basically, when a node joins and gets back from the group manager, the group ID to consider in the group at that moment, the group manager stores for long term that group ID as the birth GID of that node, and same for other joining nodes. So say at some point the group manager, for whatever reason, has to rekey the group and distribute a new GID. The group manager checks if any current group member has as its birth GID the new GID to be assigned to the group. If that's the case, well, the group rekeying that the group manager is going to perform will take that into account, and it will rekey the group in a way that those nodes are excluded, logically. So they are locked out. They will start not being able to decrypt any further message. Eventually, they will just get back to the group manager to ask for current key material, and they will get back error responses because they're not members anymore. Eventually, they will rejoin. And if they do so, they get a new sender ID, they reset their sender sequence number, and they have to kill their ongoing observation. And the original problem that forced us to forbid group ID recycling would be gone. And bottom line then, with this little addition on the group manager, groups can live forever if we didn't miss any detail here. So would there be any objection in introducing this update to admit long live? Göran?
Just to see that I understand. So what you're saying is that you're actually keeping track of group members for the purpose, I mean, in terms of the birth GID then, for the purpose when they later rejoin, if there are conflicts, so you can handle those later, or how does this solve the problem?
You check the conflict the moment you want to rekey anyway for whatever reason, and you see if the new group ID you are going to give is the birth GID of any of the current group members. Then you have a problem, and you need to exclude those members.
Yeah. Okay.
But they will rejoin, and then the problem will be gone.
Yes. Okay. So you push the problem to the group manager, essentially.
Yeah. By the way, this applies to group members that are in the group for a very, very long while to be witness of a wraparound of group ID.
Yeah, I understand it's a corner case, but still. Okay, thanks.
Thank you. Okay, next slide, please. Second and last open point, not at all less important. This was raised by Ben Keduk on the list. Supporting the pairwise mode, here we are essentially using the same identity key for two possible usages. One is, well, signing messages in group mode, and one is deriving a Diffie-Hellman secret to be used to generate the pairwise keys. And overall, it's all about the same single policy, protected communication in the group with a valid security context. But still, this double use is not exactly a common best practice. So if you go for it, you really need to prove that what you are doing is secure. And there is, in fact, ongoing work to prove that, possibly with some minor addition in the exact derivation step. This is in fact secure, at least for group of score. And the ongoing proof is trying to be built on the paper we're already referring that was focusing on the ECIES settings, although it was not limited to that. So that proof can in principle be readapted to be valid for group of score. And just as a note, the pairwise mode per se is actually all fine. The comment here is on the actual double use of a same key in the process of key derivation. So just to be on the safe side, there would be an alternative, although inconvenient, to make this a key provisioning problem and just go for two separate keys, one for signing and one for Diffie-Hellman. But they would be just inconvenient and the last resort, because it would mean more provisioning and more storage overhead, with the provisioning most likely to happen in the ACE document, defining the joining and the key provisioning with the group manager. So there is work ongoing on this, and we should be able to come back on that in the coming months. Okay, next slide, please. We should really be the wrap up. Yeah, next steps are addressing both two open points in version 12, submitted, hopefully having addressed both of them in a good enough way, and most likely that version would be a candidate to be considered to be stable to move on. Göran, please. You're probably muted.
Yeah, I was talking.
Okay.
So how is this draft aligned with the co-op group com? Is there any reason to move this before the sort of co-op group com is in the same?
They are
similar
actually
state?
referring each other normatively, so they really have to go together, more or less.
So it will be, this draft will sit and wait in the working group before until the other draft is ready.
Yeah, the same can be true for the other one, depending on which one is finished first.
Oh, okay, so what do you mean by ready to move on? What is the meaning of that? I thought that was
publication.
Okay, but will you do that before the group com is in the same state?
The original idea was to request publication for both of them together.
Yeah,
because after all, they
that makes
depend on
sense.
each other.
Yes.
Yeah.
Okay. Good. Then I know. Thank you.
Thank you. Esko?
Yeah, just a question. You mentioned doing the proof for this usage of the key for two purposes. Are you going to wait basically until that paper is, for example, accepted and reviewed before moving on this draft, or is it kind of independent?
It's in between. It's an ongoing research effort at Ericsson, actually, so probably Göran can give more details.
So there is already a draft of a paper which is intended to be a preprint. This is a colleague of mine who's been working on that, and whether that's going to be a published paper or just a sort of a preprint, it's basically building on other papers and putting things together. So it's, I mean, this particular researcher asked if this do we really need to publish this, or is it just could we have this as a note basically? But it's obviously good if we get some review on that proof. So I think that should be an ambition, but I don't think the working group. I mean, it's sufficient probably that someone from the IETF community reviews that. It doesn't have to be a sort of a presented paper. At least not. I don't think that's necessary for progressing this draft.
Thanks.
Thank you. So if there are no other comments, we can move on to the next document, which should be our score discovery with Christian presenting. Just as a time check, we are plus 8 minutes, but we have 10 minutes of flex time. So overall, we are still fine.
I'll try to keep it crisp. So this is about how can a device that is supposed to be in a group discover all the details that it needs to join the group. Just next slide, please. Giving a brief recap, the device may only know the key material, or may only know something about the group manager, but not the full joining resource, and the group manager may not even be here yet. So this is using the regular discovery mechanisms we have in co-op with a focus on the resource directory that makes the whole process more efficient. Throughout resource lookup, it receives where the particular joining node is on the group manager to join that group. Next slide, please. We've updated the document recently to largely reflect changes in other parts of the ecosystem. It's now well aligned with most of the documents that it's referring to. There are a few new target attributes that allow the joining node to identify in advance the possible groups that it could join and to see how it would join them, so making the joining process in itself more efficient. There is now a document format, and we have additional text that says that there are parties looking this up may not necessarily be joining in full, but they could also be gateways, just to cover the use cases a bit more completely. Next slide, please. Our examples are now up to date with both the link format and with Coral. And during the before and during the hackathon, we've had this running on an off-the-shelf resource directory, and Marco performed basically all the single steps that are involved in this process against the resource directory, and I could in parallel see how things work from there. So it's tested to an extent, although not for full interoperability between one group manager from here and another part from there. Next slide, please. The points that we are currently working on are mainly security considerations, most of which really are inherited from the resource directory. So, of course, a resource directory that is not fully trusted can do all those things that it can do. That is, it can hide the presence of a group. It can give wrong addresses because everything that's happening on the OS core side is agnostic of the addresses. So traffic could be redirected even though the encryption itself would not be endangered, and that's probably the worst of those. And we are still looking into how this is best addressed and which attributes this needs to be addressed. False information obtained by the client could lead to it using a non-preferred cipher suite, and this definitely needs to be addressed more clearly. Next slide, please. Other than that, it needs a bit of updates with respect to the examples with the latest resource directory changes. But most of those are really tasks that can be done in the course of time. So for us, it's really the next step would be to get a bit more comments from the working group as to, is this now something that the working group could see as useful to have inside the working group, or what kind of comments do we need to expect when this is moving forward in general. Next slide, please. So that's it from my side. Thank you. Questions, comments?
And nothing on Jabber either. So we can move to the next one on multicast notifications.
Which like the secure group communication is something that I've repeatedly presented here, so I'll cut the recap short again. Use case, so the group communication documents we've talked about so far are all about the case where a request goes out to multicast and the responses have so far always been unicast only. With this, we describe, next slide please, how responses can be multicast and where this could be useful, which is primarily when a lot of parties regularly request something and want this to have this in an observation where they can all share the data and don't have to register separately. Next slide, please. Mechanically, this happens by having a token that the server that they agree on, and the party that makes the final decision is the server, because it's the best point we can come up with. With OSCORE, this also means that they have to have a particular request that they all refer to, because otherwise the unprotection would simply not work. Next slide, please. These details are all communicated in an error response, which tells the client that I won't answer this particular request, but you can, if you were sending this request, then you could be observing, you could receive the notifications on this particular token sent to that particular multicast address, and in the protected case with this particular external AAD. Next slide, please. So what changed in since -05? Oh no, so since -04. Anyway, in the latest revisions, is that the format we have is now a bit more well defined, and also aligned with the other work we've talked about earlier about transport addresses as they would be used in proxies for group communication, which really need parts of the same data. So aligning this makes it easier for implementers to reuse code here. So what it contains is information, the server address, the group address, the token, and then a request that the client would have needed to send, and possibly a response. So if that last notification is not present, this behaves like in regular co-op an observation with an empty ACK. Yes, I heard you. The observation is fine. I just don't have data for you. If there is data in there, that can be expressed just as well. Next slide, please. That array is, just like in the proxying case, also extensible. So if currently there's only one transport that can handle multicast, that is co-op over UDP, which is something that involves a server host, a server port, a client host, a client port, and a token. If we ever have any other transports that behave completely differently, we have the extension point there to say protocol, say 2 is, or probably some higher number, because proxying might take different numbers as well. That number is co-op over what's or not, plain LoRa, I don't know. Next slide, please. We're now more explicit in that we do not negotiate for this feature. This is something we had in very, very early drafts, but removed it because the use cases that we see are the ones where it's not feasible to cater for an individual client's request. So if you do see use cases where some clients might be observing resources individually and others might just switch to the large pool of multicast recipients, please tell us, let's talk about it, and then we can figure out whether this is something to specify right here, or whether this is something that still can be addressed in an add-on document. Either way, the server can announce its support for these group observations with a target attribute that we now describe. Other than that, we've updated all the examples to work correctly with the text that we have. Next slide, please. And also cover how this could still be improved by using a deterministic request as a phantom request. Thing is, thinking back to the examples, when you compare them, it's like such an exchange for the unprotected case and such an exchange for the protected case. This really doesn't go well with the story that we like to have OSCORE as something that you can just tag onto co-op and then with a minimal overhead that's cryptographically feasible, do all your exchanges, but do them in a protected way. By using deterministic requests, we can get this whole litany of exchanges down to the compact form that we have in the unprotected case. And just not to forget the point, another update we did was we now describe better how a device can act as its own group manager for those very simple cases where there is no pre-existing infrastructure around. Next slide, please. So there's still a bit work to do in giving concrete examples for these deterministic cases and in exploring a bit further how that would work in a reverse proxy case, which might to some extent also relate to the reverse proxying work ongoing in the with the general co-op multicast proxying document. But as with the other document, we are at a point where we can still improve things, but we would be improving those parts. We start improving on details, where I think this could profit a lot from more interaction with the working group and from deeper reviews, possibly in the course of a working group adoption. Yeah, next slide, please. So this summarizes what changed here, and also how we would like to have more input from you. Thank you.
Please, Esko.
Yeah, just a question on the appendices. So there seem to be quite some appendices now. Are these then intended to be just examples or clarifications, or also something normative?
Let me just go through them. So most of them are currently examples. The part about the deterministic requests is really just illustrating how those things interact. So that there is no need for any normative additions, but more explanation and implementation guidance. Especially with deterministic requests, it helps a lot to. If you're in the right mindset, then you understand why this all works. If you're viewing it from the wrong angle, then it sounds awfully complicated, and this is more to get you on the right track.
Okay.
Appendix C is something that would probably have normative content, but not interfering with the rest of the document, but more specifying, registering additional attributes and specifying a method, basically specifying a very simple way of managing a group.
Okay, thanks.
Any more questions? Göran?
So, what are the main things you think are missing here, except from I mean reviewing and testing this scenario? What is that? Is this are all the components in place now, do you think?
The components are in place, yes.
And only the details on exactly how
there
things...
are a few details to hammer out, and on coming back to the part of is everything in place? Like many group communication documents, this is all assuming that the groups are set up and that we are starting in this from a situation where everyone knows which group to be in, etc., etc. So possibly there could be enhancements there. Frankly, I don't know all the documents that are in progress around that well enough to say whether there are maybe things already there that we could just reference.
Okay, so I mean, so looking at this from this particular piece of handling the multicast notifications, then that this is fairly complete in your view, except
Yes.
for details and reviewing and testing. Okay, thank you.
Yeah, there was a point on possible adoption in the last slide. Karsten, do you want to take over on that?
Yes. Takes considerable energy to juggle this environment. I'm sorry. Yeah, so this is a document that is in version 08. Sorry for already putting up the next set of slides. There is...
Sorry, Karsten, just to be sure it's the right document, it should be really version 5.
Yes, sorry.
Okay.
I'm very confused here. Yeah, so the multicast notifications has been discussed for a while, and it's version 05. And what we have to decide as a working group is that something that we want to work on? And is the draft actually doing going into the right direction? Not is everything already exactly like it needs to be. So I'm going to start a poll on that. So please go to the yellow thing at the top of your window and raise hands if you think we should adopt it. Okay, the number is still increasing. Okay, I think we have reached our final count here. So we have 13 people who think we should adopt it. And now let me ask the opposite question. So who would oppose adopting this document? A lot of people make sure it's known that they do not oppose it. Okay, so the number is still increasing. Okay, so that looks like a pretty good in-room consensus. And of course, the question is, who's going to provide reviews of this document? Can you just use the show of hand queue thing to indicate if you are interested in providing reviews? Esko, Jöran, okay, and let me ask about the implementation status. Who has implemented a version of this? Jöran? No, Jöran is going away. So who is planning to implement this? Christian? Marco? Yeah, would be nice to have a non-author implementer to make sure that this is actually implementable for people who haven't invented it. Christian, do you want to say something, or are you still in the showing hand queue?
No, I just didn't get my hand down in time while typing.
Okay, thank you. Yeah, okay, but that's not a prerequisite to adopting the document. So we do have energy implementing this, but again, it would be nice to have implementers outside the author group. But then one problem we often have is that people who implement something are being sucked in as authors, and so we never get somebody who is not an author as an implementer. Okay, so we need to validate this consensus on the mailing list, but this looks like a pretty strong result for in-room consensus for adoption. Okay, with that, I'll hand over to Esko.
Just a time check, we are +9.
Yeah, so I'll skip the examples, I think, because that takes quite some time to go through. Okay, now about the proxy operations for core group communication. Next slide, please. So as an overview, well, we have, of course, group communication in co-op, and this document contributes basically what a proxy could mean in doing group communication, facilitating group communication. And its aim is to also address the issues that were found well, already a couple of years back and now also written up again in the GroupCom-BIS document. So these are addressed by providing a signaling protocol between the client and the proxy using co-op options. And responses are individually forwarded back to the client in this case. So that's the basic idea. Okay, next slide, please. So you can take a look at the picture to see how it works. So the client sends a unicast request to the proxy, and basically should indicate there in an option that it's interested in handling multiple responses coming back from a group request. Also, it should indicate how long this proxy should collect and forward responses. So we assume here a proxy might be a generic one that doesn't know how long the client wishes to collect responses, so it can basically signal that using multicast signaling. The proxy will remove this option and then send out a normal group communication multicast request to the servers. And when the responses come back in, the proxy can basically see from what server the responses are coming, and it can add this information in a new option. So this is the response forwarding option. So this helps the client to distinguish the multiple responses and also the different servers where these are coming from. Security can also be supported here. So end-to-end, for example, between client and servers using group OSCORE. And in addition, also normal OSCORE can be used between the client and the proxy, shown in an appendix, or it can use DTLS for that unicast connection. Okay, next slide, please. So the updates that we did. So we have now a new, I think a new format change for response forwarding option. So we basically have this alignment to the format that Christian also showed before. So there's a specific transport information encoding where we use the value 1, for example, to denote UDP, transport protocol, and also the IP address where the server was located, and optionally also a port if needed. So that information is then communicated back to the client, so it can, if needed, also contact the server directly or via proxy using unicast. Okay, next slide, please. So also there is this registry that's being used. So I already explained the value 1 being UDP. There can also be other values there, so that are encoded here in the table. So that's what we want to add to this transport information registry. So you can have things like UDP DTLS, secured co-op, co-op over TCP, co-op over TLS, WebSockets, and then also WebSockets with TLS. This can normally, you could say the value is always 1 because the server responds back in UDP unicast, so that would be the transport protocol 1. But there are some specific cases, for example, with reverse proxies, in which other transport protocols could be defined also for the responses. Okay, let's go to the next slide. One new thing is that now also reverse proxies are considered. Before we had explicitly only the forward proxy scope, but since many things apply also to reverse proxies, we can take that in, I think. There was one item here that I added a note that could still be under discussion. So the initial idea we have is that the client basically must be aware of that its server it's contacting, which is the proxy, in fact, that it is a reverse proxy. And it also must use the multicast signaling option to signal that. I think there are some cases where it can also not use that option, and the whole proxy can still work as a reverse proxy. In this case, the proxy then picks the the time, basically, how long to collect the responses based on its application knowledge. Furthermore, for the rest, for the reverse proxy, the client acts similar to the case of the forward proxy. It's only that the encoding of the request is a little bit different. We also added in the option that the proxy can basically, it looks initially like a normal server, but it can reveal itself as being a reverse proxy by sending back this multicast signaling option with an empty payload. Okay, that's new. Go to the next one. See, you have some more updates. Oh, this is the example. So I would like to just go over that because I think it takes quite some time, but you can read it in the slide material. It shows basically what is added there and also what the values are in this example case. There's a forward proxy and a reverse proxy example. I actually would like to also add in the future an additional reverse proxy example, so that shows a bit of a different way in which it could work. So I think it is quite a broad spectrum of reverse proxies and how they can operate. And we'd like to show some examples of that. So now for the security, of course, we again depend on OSCORE for group communication security. So we can have OSCORE between client and proxy, coexisting, as I said in the beginning, with group OSCORE end-to-end between client and servers. And then there are some intricate things about the options, class U and class E. So the proxy will have to treat some class U options as if it was class E to make that all work. Of course, there the point is, what about future options that will come in co-op? So do we already know how the proxy should treat those? So for that we have a more general rule added. Still a question if this rule is indeed accurate or simple enough to understand. I think it's also written there in text. So what is the general rule for that? I'm not sure, Marco, did you want to discuss that now or take it at the end maybe?
This was mostly echoing an input we got from Christian about this to simplify the text more or less this way, I hope. Mm-hmm. Otherwise, the bigger open point is the next one, I think.
Okay. Well, then maybe move to the next one, just to, to see that. This is about the nested OSCORE. So the idea is to have end-to-end OSCORE to the servers and also OSCORE between client and proxy, independent from that. So before it was actually forbidden to do that, so because there was no use case and it seemed complex, so that's why it's not supported at the moment in OSCORE. But now we have a use case basically, so at least we see that can work well in principle. Then the question is, of course, what to do with this as a next step. So now we have it in an appendix, and it takes quite some explaining, I think, to get it right, how everything works with nested OSCORE. So I think the question is, should it be maybe going to a separate document that explains this, like an update to the RFC?
Please, Joran.
Yeah, I think this makes sense. As you said, the reason why this was not defined was we didn't have a good use case, and that all these considerations around the class U and class E options, how that changes when you designate certain information for the proxy. I had one question though about what is so I mean, there is also always the option that you can have a separate communication with the proxy, sort of one OSCORE communication with the proxy, and one with the with the other endpoint. So what is the information carried in that needs to go the same in the same message? So I mean, the question is, why do you need to have two separate? But why do you need to have one connection instead of two separate connections?
The idea was that you want to reach the outer servers or server in the first place through the proxy for different reasons, and you want to protect end-to-end, but still the proxy has to identify the client in order to proceed with the forwarding in the first place.
Right. Okay. So there is a good reason why you want to do this.
Yeah.
In one message.
Yeah.
Okay. Yes. Yeah. Authentication of the client, also at the proxy side. Yeah.
Okay. And I think this should be defined separately rather than built into this document. And the analysis of the different values of the options should then go into that document. I think that makes sense. There are also the question: is this something we should define as? I mean, should this be recursive? So you could have a lot of proxies along the way, and you protect for each in turn, or should we have a limit to that? We need to think about message expansion. If each proxy for each proxy you add a tag, for example, and then the message grows. So there are a number of things to think about, and I think a separate document would be the right place to elaborate on that.
Okay.
Thank you, Göran. John, go ahead.
Yeah, yes. I think one problem that we discussed when we wrote the OSCOR document was collision of recipient IDs and sender IDs. So you need to basically divide it between the different layers of proxies and the endpoints. Nothing that can't be solved, but.
Thank you. And Christian.
I think this collision issue will turn out to be much less of an issue than it seemed, because the messages in which the messages that are sent all have their routing information to wind up at the right device, and information that targets different device will only be forwarded from there and not arrive there. We'll see when implementing, but I'm pretty confident this is not really an issue.
And you're also supporting a separate document on Jabber for the minutes.
Okay.
Thank you.
Right, and maybe let's move to the next steps, if no more views on that. So in summary, we have defined proxy operations for co-op group communication with an explicit signaling protocol using these two new co-op options. And yeah, as a next step, what we thought about was also to take HTTP in the content, basically. So we could imagine that the proxy can be accessed via HTTP. So then the client can talk to a co-op group in that way. So that can actually build on the previous work of the HTTP to co-op mapping proxy. That's already in RFC. And there was also a couple of other issues listed on the GitLab. So we also need to continue with that. Yeah, I think more reviews, that's the standard end line for these type of presentations. Yeah. I see. Okay, there's two promised already. Okay, that sounds promising. Christian and Karsten. Great, thank you.
Thank you, Esko. Okay. Next in the list is Christian again with cacheable OSCOR.
Just to set my pace, how are we on time? Because I didn't find the.
We are plus 14.
Okay, then I'll try again to make it short. Topic of this is is deterministic requests as a means to obtain cacheable OSCORE. Next slide, please. Thing is, so why do we want caching? Basically for the same reasons we want it in general. In particular here, firmware updates are something where we can reduce the amount of traffic. We can also hide how many devices are behind a proxy. They just produce cache hits. And we've in research work shown that kind of this greatly increases the reliability and latency, as is to be expected. And last but not least, this greatly enhances multicast notification. Next slide, please. The reason this is not trivial is, for one, OSCORE requests are designed not to be cacheable because generally they can't be useful to another client. And even if we could magically produce a cache hit, the client would still need to know some data of the original request, like the KID, the partial IV. And even if it knew that, it couldn't verify that the original client really sent that request, and it's not handing you another request just underhand so that you interpret the server as a good response to that. So that's the rough problem area where this is coming from. Next slide, please. The mechanism that's proposed, and I'm including parts of the upcoming -02 because those things just became apparent in the plug test, and I think now this is the best way to go. But largely is unchanged. Is there is a deterministic client. That's a role inside the group we define. That's not pertaining to a particular host, but every group member can take that role and generate requests from there. To make sure that these requests do not collide on anything accidentally and thus commit nonce-reuse and thus make all the crypto stuff go boom, we introduce the request hash, which is the hash of the sender key, the external AAD, and the plaintext. That is everything that goes into the encryption mechanism. So provided that we have a deterministic encryption algorithm, which all of the current algorithms are, we don't really commit nonce-reuse because we're using the same nonce to encrypt the very same thing and thus bit by bit produce the same request. This hash is then fed into a key derivation mechanism that is very similar to the one that we use for pairwise, and generally the mechanism is very much like a pairwise request sent from the deterministic client to the respective server. How this is done in particular is still open to discussion because Göran already gave very good feedback on this, and this just needs to be evaluated and made into concrete steps. The server then recognizes the sender key ID, obtains the key material, and at the latest there notices, oh, that's not a regular client, that's the deterministic client. It can use that hash that is sent along with that message to reconstruct the key material, verify that it's a correct, that the authenticated encryption works out, and verify that this hash really matches the sender key, AAD, and plaintext that it finds. So we have additional protection against all those things that we'll hear about in 10 minutes. Next slide, please. That leaves open the question of how does the client, when receiving the response, verifies that the response is good, because so we can't have pairwise responses. We have to have the responses from the signed by the server, so that every client that receives the cached response can be sure that it is really from the server and not just from someone else who is member of the group. For that, the current way to go is to have a class I option that includes the request hash. This does not necessarily need to be sent on the wire. In fact, it's recommended not to send this because it's redundant, but it's placed in the co-op message before it gets handed to OSCORE, and thus we get this strong message, the binding between the request and the response, and the client that produced the request can be sure that the response it gets is for that response, and by verifying the signature that is coming from the server. Next slide, please. There are a few limitations on this, of course. The main thing is we are trading this for that, so no new features without giving up something. This only works for safe requests. Kind of, I mean, it needs to be cacheable, so it can't just be, process blah and then the result is different every time. It only works for things that don't have additional access control based on source authentication, because we lose source authentication deliberately. We're limiting the set of algorithms a bit. We lose the chronological, basically the freshness guarantees that usually an OSCORE request gives you, because we want to get responses that were created before the particular client even created the request. We lose on request confidentiality, because we want a proxy to be able to collate different requests for the very same answer into the same bucket. And we do lose replay protection, because that which is okay, because we're only talking about safe requests. Next slide, please. So during the hackathon last week, Marco and I interoperated to the point where we could decrypt each other's deterministic requests. And if we do a few more steps, I'm very confident that we can even pass the responses for that. We have comments already from Göran that we are still reviewing, but once that we are still incorporating into the document, but once they're done, it would be really good to get a review from this in a kind of, in the sense that people who did not come up with this go through the claims and verify that we are indeed preserving all the properties that OSCORE is claiming. In parallel, of course, we'd like to continue our interoperability tests and thus give this a bit of a more practical testing. Yeah, thanks for listening. That's it from my side. Comments, questions? Esko?
Yeah, just a question. So for the deterministic request, basically, you cannot really determine the order, right, in which requests were sent, or
yes,
the problem. You cannot prove that this one was sent later than the other one.
Yes, because any other client in the group could have come up with that request earlier already, or could produce the same request later. They are not ordered.
But you can actually, for the server responses, that you can probably order easily.
Yes, so that's the ordering of the server responses is still good, and thus you can still use it for observations and see what the latest is. But you cannot know that the response you're getting on that observation is really later than the request that you just sent.
Mm-hmm. Yeah, and not exactly which request it was linking to, basically. Yeah. Yeah. No. Okay. Thanks.
Okay, thank you very much. Next in the list is Richard, presenting a combination of ad hoc and OSCORE.
Yes. Hello.
Hello.
Yeah. So we're just waiting for the screen sharing. But as Marco said, yes, I will be presenting a work that's ongoing about how OSCORE and ad hoc can be combined. Yes. Yeah, next slide, please. Yes. So just to recap what this work is about, it's about an optimization for combining ad hoc over co-op with OSCORE. And this means that you want to combine the ad hoc message tree and the first subsequent OSCORE request in a single co-op request transporting both. And basically the point of doing this is that it reduces the number of round trips required to set up the OSCORE context, and also to complete the first OSCORE transaction with that context. And the point is that after a client has received ad hoc message 2, it's already in a position to derive the actual OSCORE context. So at that point, the client can send an OSCORE request, and we want to combine that with the ad hoc message 3 from the client. And the exact contribution that we propose here is, first of all, how to signal that what you're getting here is a combined request, a combined message. Also the format and the processing of the ad hoc plus OSCORE request. And we also show an example of the data here, the EDOC and OSCORE request encode, and how that would actually look, how that combination would look. Next slide, please. Right, so basically this is the original way. If you would do EDOC first, EDOC message 1, EDOC message 2, EDOC message 3, and then you derive the OSCORE security context, and then you do the actual OSCORE request and response, right? So that's the original way without this optimization we propose. Next slide, please. And then you can see here the optimized way. So basically, the client sends EDOC message 1 and gets EDOC message 2, but at that point, it can already derive the OSCORE security context on its side. And at the same time, it can produce EDOC message 3, which it does. So then it would send one single request here, combining EDOC message 3 and that OSCORE request. And then when the server receives that, it can take EDOC message 3, derive the OSCORE security context, and then actually, let's say, decrypt the OSCORE request, and then provide an OSCORE response. Yeah, next slide, please. So basically, the updates now to this latest version is that we decided on a single method for how to signal the combined message. And that method is basically using an option, a new option, which is a zero-length option, class U for OSCORE. And its intended use is only for this EDOC plus OSCORE request. So when you get such a request, you can understand that, okay, this is a combined EDOC and OSCORE request by the presence of that option. And the reason we chose this is partly because of preference expressed during the IETF 109 meeting, but also feedback from implementers, because we also have an implementation of this and got some feedback from the person implementing that. And we also propose in the draft a suitable option number 13, because we want to keep the size of the option to be 1 byte, right? And the idea is that, like I said, it's a zero-length option, and we assume in this combined request, the OSCORE option will always be there. So we know that, if we pick option number 13, the delta here for the EDOC option will be less than 12, and in such case, it will be a 1 byte option. And as a note, option number 21 would be another suitable value that could be taken. Next slide, please. So here is basically an example of this combined EDOC plus OSCORE request, where you can see in the top box, the blue box, just kind of the structure, how it would look. So you have the normal header there with the OSCORE dummy method. You have the OSCORE option with its normal content. Then you have this 0-byte EDOC option. Following that, you get the actual EDOC payload, and then also the OSCORE ciphertext. So you combine in the payload the EDOC message 3 and the OSCORE ciphertext, essentially. And in the lower part, you can see kind of the message overview. So you have the OSCORE option and the EDOC option, and of course, any other options, if there would be any. Yes, next slide, please. And yeah, further updates we have done. So just overall section restructuring, editorial improvements. Since now we decided on a single method for signaling, we restructured the text to suit that better. We also have a better step-by-step description of the message processing, where you can see detailed steps on exactly what to do on the client and server side. So as a kind of an overview, what you would do on the client side when you're the initiator, you would prepare EDOC message 3 and an OSCORE request, combine those two, as showed earlier, and send that to the server side. And on the server side, you receive this combined request. You can extract and process EDOC message 3, and that allows you to derive the OSCORE security context, and then that allows you to process the actual OSCORE request, which is also a part of this combined message. Yeah, next slide, please. And we did also another optimization, because there was some redundant data as things were in the previous version, and the redundancy is due to the fact that the the sender ID of the client is actually present in two places in this combined message, as things were. It was both present in the CR in the ad hoc message tree and in the KID field of the OSCORE option, because those are basically the sender ID of the client, essentially the same value there. So we thought that we could avoid this redundancy in a clever way. So basically the combined request we send only has a partial ad hoc message tree that does not include the CR, but only the ciphertext tree as a CWOR byte string. And this optimization can actually save 2 to 4 bytes on the wire. But the point is that when the server then gets this request, since the ad hoc message tree doesn't include CR, it needs to get that value from somewhere, but that same value exists in the OSCORE option in the KID field. So it can simply take it from there, encode it as a byte string identifier, and rebuild the full ad hoc message tree as it would have initially been created on the client side. And then it can process that as a normal ad hoc message tree. Yes. Next slide, please. Right. And further updates, we improved the error handling on a number of points on the server side. So basically, we detailed exactly what should happen when the ad hoc part of the processing fails. And this included suggestions for what error code to respond with, and the fact that the error should have a content format to help, because you have to disambiguate in a sense between the failure on an OSCORE processing and failure on an ad hoc processing. So we added some considerations on that can be made easier. So in the case of ad hoc processing failure, you return an ad hoc error message, and this is a non-protected response, right, to an actual OSCORE protected request. So here, to be consistent with the OSCORE RFC, you should use co-op error codes like 400, 500, for instance. And it should also have the content format application ad hoc, like I said, to distinguish it from OSCORE errors. But as far as OSCORE processing, is exactly as in the OSCORE RFC 8613. Yeah, next slide, please. And yeah, next steps we have planned. So the first one is basically to keep in sync with the main ad hoc document. There was some discussions on what points fit better in the ad hoc document and what points fit better in this ad hoc combined with OSCORE document. For instance, some things specifically about co-op and OSCORE may fit better in this draft here rather than the main ad hoc documents. So we should sync a bit with the work on the main ad hoc document here. And of course, any further feedback is welcome that anyone wants to provide. And as the last point, we got good feedback, I think, from the last meeting, and also good feedback from implementers. So yeah, from our point of view, it should be ready for working group adoption at this point. Yeah, next slide, please. Yeah, thank you. That was the last, and you can see the link there to the repo where this work is ongoing.
Question, just quickly, maybe you could recap. So what's the purpose of ad hoc about? Because maybe not everyone knows on this call what it's doing and what it's for, and the combination.
Yeah, I mean, the purpose of ad hoc is basically establishing keys for OSCORE in a secure way. And the point of this optimization is just to reduce the round trip times. And because you have an opportunity to combine the last basically ad hoc message tree with an actual first OSCORE request, so you reduce the round trip times. Rather than doing ad hoc and then OSCORE, you do ad hoc and you combine one of the messages with OSCORE. And you can more quickly establish communication with OSCORE in this way. So that's the main point.
Yeah, thanks. Okay.
Yeah, any other questions?
There is also a +1 for adoption on Jabber from John and from Christian.
Okay.
So I don't know, Carsten, if you want to take it over again on this.
Yeah, I think we need to do a formal poll here again. So first of all, a quick sanity check. Yes, I think we can do this in the core working group because it's not actually changing the security content of ad hoc. It's just transporting the ad hoc message in a core message, and that's within our purview. So I think that that's an important observation. And so I ask the question, should we adopt OSCORE ad hoc? So I assume that all the people who have +1 in the Jabber will raise their hand here as well. Okay, so we have one do not raise hand, so that would be interesting to find out why. Let's finish this call.
Yeah. I can maybe explain that. So I thought, yeah, there should also be someone not raising their hands, basically. Yeah, that's because I wasn't quite sure. So it's not against, but it's just not raising the hand.
Yeah, so I do the real oppose question. So to really oppose it, you can raise your hand here.
Yeah, no, that's not the case.
Okay, so we seem to have strong non-opposition to adopting this. So again, this is in-room consensus, and we need to take this to the list. Thank you. So we are 7 minutes late. So I'm not going to ask about implementation this time, but please, if you are working on this, send a message to the list so we can gauge this. So, Richard, you're next as well.
Yes, indeed, yes.
Yeah, we have 13 minutes to go, so please try to compress your presentation if possible.
Yeah, I can try to keep it brief, yes.
Start talking.
Oh yeah, there we go. Yes, so again, Richard again. So I'll be presenting here a work on AAD key usage limits in OSCORE. Next slide, please. So basically this work started, or discussions about this started in earlier meetings like IETF 109, also related to Lake. And basically the overview here is that OSCORE uses AAD algorithms to provide security properties. But there is this forgery attacks against AAD algorithms that have been described, for instance, in this CFRG draft that you can see there. And the point here is that adversaries may break, under certain circumstances, the security properties of the AAD algorithm. And there's a need, in the case of OSCORE, to consider how this attack impacts OSCORE. Basically, how does this forgery attack and the limits affect OSCORE, and what steps should you take during message processing to consider these findings? Next slide, please. So essentially, to avoid this or to protect yourself against this, you need to count certain things. So you need to count this Q value, and the Q value is the number of messages protected with a specific key And you also need to count the V value, which is the number of forgery attempts that have been made against a specific key, which means the amount of failed decryptions done with this key. And for OSCORE, there will be essentially two relevant counters. The number of times you used your sender key for encryption and the number of times you used your recipient key for decryption. Next slide, please. And this is an overview of how you could calculate these limits for the AES-CCM 1664-128 algorithm. And some of this depends on what probability values you chose. We chose the same as in the DTLS 1.3 document that you see linked there. And by applying these formulas and inputting certain probabilities, it will give you a cap, like a limit on the Q and V values. And essentially what it's saying is if your Q counter, the encryptions, reach your Q limit, you should stop using this key. And at the same time, if your V counter reaches the V value, you should stop using this key. So it's like limits on when it's not safe to use these keys anymore. See, Göran's raising his hand.
Yeah, I just want to say that John is coming back to these limits. You don't need to go into depth of those.
Yeah, next slide, please. Then yes, we can proceed. So this is just overview what you should introduce in those core security context. Like I said, you need basically a counter for Q and a counter for V, an associated limit for Q and associated limit for V. And if these limits are reached, you must stop using that security context and you must rekey. So, and also, by the way, this updates RFC 8613, the OSCORE RFC, because it introduces these new things in those core security contexts. Next slide, please. Okay, and also the draft goes over existing methods for rekeying OSCORE. And presently, you basically have 4 methods, which is the Appendix B2 of OSCORE. You have the OSCORE profile of ACE, you have the ad hoc protocol, and you also have manual reconfiguration of the nodes, which is not practical. And in the draft, there is a brief description of each of these methods and what benefits they bring. Next slide, please. Open points. One point is, if we now produce more limits for further algorithms, which our intent is, what's the best location to add these? Is it in this document or is it in even some higher level document? Because this could be general per algorithm, or it could possibly also be general per use case, like specifically for OSCORE, you know. Second point is, what about these probabilities we assume? Would they be different in the case of OSCORE as, you know, what DTLS 1.3 would define? And the third point is there a value in adding an expiration timer to the OSCORE security context, meaning an actual time limit saying that when this many seconds has elapsed, this OSCORE security context is no longer valid to use? It's similar to the XI parameter in ACE. And by the way, group OSCORE also does something similar to this. When you join a group, you can get an expiration for the group security context material, so that it basically expires at a set moment in time. So an open point is there a value doing this from a security perspective? Next slide, please. Yeah, and this is our planned next steps. So basically the summary is we're introducing counting of Q and V values for OSCORE. You have to stop and rekey if the limits are reached, and we provide an overview of current rekeying methods. Next steps, we need to cover more AAD algorithms. We only cover one, which is the default and mandatory to implement now, so we focused on that. It also has a short tag, so we felt it was more relevant. Secondly, synchronize with other ongoing work like ad hoc in Lake, and now the presentation upcoming from John also. And finally, we plan optimizations for constrained devices and further implementation guidelines. Next slide, please. Yeah, thank you. That's it. And here you see the link for the repo.
Thanks, Rickard.
Thank you.
So next is John taking this problem from a broader perspective even.
Yeah, let's see if I can summarize this in 5 minutes. So this is a more review of the process that was used for DTLS, TLS, and QUIC, and the findings based on that, especially how it relates to OSCORE. Next slide. So I think that has been summarized, but rekeying also have a lot of other benefits. So I think you should always do rekeying with forward secrecy if you can. Next slide. So basically this AAD work in TLS and CFRD and Quick has 4 parts. You can see it. It starts with inequalities, and these are inequalities. They are not tight. They illustrate the worst case. Then you have a process and some limits, and these are not objective mathematical objects. These are very subjective. And as we will see, they can be improved a lot, especially for CCM8. Then you come to AAD limits, and then you use them in the protocol as Rickard. And I think the AAD limits for TLS and DTLS are mostly nice until they started to do DTLS limits for CCM8. Then you start to see the limits of these process. Next slide. First, I think this is just AES is basically assumed to be perfect, a perfect permutation in all these inequalities, but Cha-Cha 20 is given a horrible limit. In fact, in the paper, it's assumed to be a perfect pseudo-random function. So I think it would be more reasonable to set CA equals to 0 for that. That doesn't really matter. We can move on. Then analysis of the step. The process used in DTLS leads to a lot of strange things. For example, that you should rekey the ideal MAC, like the perfect MAC, which doesn't make sense. It also gives the image that you can, with frequent rekeying, you can reach arbitrary high security, which is not at all the case. In fact, some of these inequalities doesn't benefit to rekey at all. Next slide. And you can basically see that very easy from the inequality if it benefits to rekey. If it's linear, then there is no benefit to rekey. You can press down the advantage per key, but that doesn't really matter. It's the wrong thing to measure. If you have quadratic or superlinear inequalities in general, then there is a benefit to rekey. Next slide. So, and also notice some other things with the values in DTLS. Q equals 2 to 23 and 2 to the power of 10 are a bit high. This leads to that CCM deviates from a perfect MAC for low V. Just lowering these numbers a little bit fixes this. And yeah, we think a better solution, but we don't argue that that's the optimal solution. But a better thing to do than the process in DTLS seem to be to either just look at the inequalities, the graph from them, or to calculate security levels based on these inequalities. And the easiest approach seems to be to calculate security levels. And that is next slide. These have the benefit that they, so here are some graphs in general, and you can see security level. The security level, you need to rekey before these graphs drop down to too low security level. But in general, the security level is the minimum of all the allowed values on the x-axis. And the different colors here, blue is the DTLS values, and purple here above is if you reduce these numbers a bit. So for example, to Q equals 2 to the power of 20 and L equals 2 to the power of 8. And notice that all these are inequalities. The security level is between these curves and the green line up there. And next slide, and I think we're running out of time. What do the chairs want to do?
Yeah, we're just on the clock. In case consider to skip to the conclusive slide. We'll go back to this during interim meetings for sure.
Yeah, basically, but I haven't concluded. I think we need to go back to the slide somewhere, but basically there is perfectly fine to use CCM8. It can be used for a long time without rekeying, and rekeying doesn't really help at all.
Perhaps we can continue 5 minutes. Is that okay with I mean, those who can stay, couldn't we stay?
It's mostly me, Teiko, that can close the session in a few minutes, but as long as we can stay, sure.
Mm-hmm. Then let's go back 2 slides. Here you just see how to calculate the actual security limits. The security limits are not where this horizontal line crosses the curves, but it's the minimum of everything to the left. Then we can go to the next slide. This is maybe now the 2 more interesting slides for core. So this is CCM8, and to the left you see the security level using the DTLS values. You can see that CCM8 deviates a bit for low values of V, that's forgery attempts, and also for high values. But in the middle, it works like a perfect 64-bit tag. It couldn't be better. And to the right, you can see that changing these values a little bit, so you have a little bit lower, shorter messages and a little bit lower Q, then CCM8 or 8-byte CCM behaves extremely close to a perfect MAC all the way until 2 to the power of 35 forgery attempts. And rekeying here doesn't really improve the security at all. So my conclusions are the opposite as the DTLS values. CCM8 is, as long as you can accept 64-bit tags, then CCM8 is basically perfect. So next slide. So conclusions, what Richard proposes is definitely necessary. You need these counters and you need rekeying. Rekeying is also good for other things. CCM8 is perfect as long as you can accept 64-bit tags, and 64-bit tags should and can be accepted. It's basically, especially for constrained IoT. To produce a single forgery, you basically need to send 4.3 billion messages per second for 68 years, and this is very infeasible in constrained radio. I think OSCORE should consider using some smaller values for Q and L. Then you get then CCM8 starts behaving for a long time, has the perfect MAC, and then last down on this slide some suggestions, either to do a little bit different values for the different algorithms, for example 2 to the power of 20 for GCM-CA and ASCCM, but you could allow V equals 30 for CCM8 without problem at all, even a bit higher. Or should OSCORE do something simple and simply say Q and V is 2 to the power of 20 for all algorithms. And then also I think the message sizes should be lowered a bit, maybe to L2 to the power of 8, which is 4K, which would be instead of the 16K in DTLS. Comments, questions? Everything is perfectly clear. Great.
There is Göran in the queue.
Yeah, but we probably don't have time to discuss details here, but I think we need to think about where, so what work goes where, and where we would put this type of, if this would analyze some separate document. Do you have any idea, John, on where this work would be published and how it would be published? Which working group and so on?
I'm not sure. It should need to be published. Here is to give input to how OSCOR chooses its limits. And also, I think one conclusion is that I don't think the DTLS process should be published by CFRD as a recommendation. I think it's quite flawed. The actual values that are used in DTLS and TLS, on the other hand, are quite good and improve security, except for CCM8, where I think the process starts to have limits.
But the actual process updating is not really something for the document recap presented, right? Something for somewhere else, I guess.
Yeah, I'm not sure it needs to be published at all. I think this is recommendation how research document should choose the limits for Q&D.
Okay.
Maybe it should document shortly how it did it, but not in any long text.
Thank you. Any other quick input for John? No. Okay, then with 7 minutes over time, I think we can adjourn the meeting. Thank you everyone for attending today and the discussion. We have a second session on Friday at 12 UTC. Enjoy the rest of the week.
Thank you, everyone.
Thank you.
Thank you. Bye-bye.